Okay, colleagues, I think we can't waste any more time. We discussed us starting on issues. Um, these issues in a distributed system operating system. We actually did indicate that in designing a distributed operating system, we said that this is more difficult than just designing a centralized system for several reasons. Okay, we gave quite a number of reasons as to why um, there's complexity or difficulties in designing system targeted for use on distributed environment compared to just the one that is used under the centralized system. Um, we did actually say that um, in the design of centralized operating system, it is assumed that the operating system has access to complete and accurate information about the environment because this is designed with the fact that you understand your environment, you understand where the will be operating, the networks, the computers that are connected to the network, and so on. So this makes it quite easy to be able to design the operating system for centralized system, unlike for decentralized. Okay, so we said a centralized operating system can request status information, okay, being shared, that the interrogated component will not change state while waiting a decision based on that particular status information. Since only a single operating system asking the question may give the command. So in short, we did indicate that they are quite straightforward because the environment is known. So even when issuing certain text or command, you find that this happens to be straightforward. The the decision that is being taken is only done by a single operating system whose environment is already known, such that in case of anything, you will have to troubleshoot by looking at each of the connected segment. Okay, each of the connected segment. Now, we said that in a distributed system with the assumption that complete information about the system environment will never be available. It may never be possible. It will never be possible. The computers connecting or communicating via the on the distributed environment. Okay, we will know about the location of each other. Look at certain issues of transparency so that certain kind of information is kept hidden. Okay, so in a distributed system, the resources are physically separated. They're physically separated, and there is no common clock among the multiple processors. Delivery of messages delayed, and the message could even be lost. So you cannot hold any computer responsible because you don't even know where they are located. Where they are located. So the resources are physically separated. No common delivery of messages is delayed. So due to all these reasons, a distributed operating not have to be up to date. Okay, consistent knowledge about the state of the various component of the distributed system may not really be. Okay, so a distributed operating system does not have up to date consistent knowledge about of the underlying distributed system. So a particular system may not have a complete information about the status of other machines that are operating on a distributed environment. Okay, so this may not lack of and consistent information, okay, makes many things such as management of resources and the synchronization of cooperating activities much harder in the distributed operating system. Okay, lack of all this information where you don't know the status of other machine you are communicating to. So this one makes it in the design of the distributed operating system. As an example, it is hard operating system is not sure how many of them are up at the moment. So you cannot schedule the processor because schedule a processor in which way, in terms of the job that are coming to the processor. Okay, you cannot really schedule that optimally because you don't know the status of other um, other other processors, whether they are up and running, whether they've got resources uh, that they are willing to share, and so on. So this becomes quite difficult. Okay, this becomes quite difficult. Okay. Now, despite these complexities and difficulties, a distributed operating system must be designed to provide all the advantages of a distributed. So all these difficulties we are talking about, the users of the system shouldn't know to say, this is what is happening. They shouldn't know. Okay, you are a designer, you must be proactive in the background to ensure that the user is not aware to say there are all these challenges that are incurred, that are taking place in the background. Okay, so that is, the user should be able to view a distributed system as a virtual centralized system that is flexible, efficient, reliable, secure, and easy to use. So this is the goal of the designer, of you as a designer um, distributed operating systems, or the operating systems that are used on a distributed environment. So we are saying, as a designer, um, you must be able to ensure that your users are able to view as a virtual centralized system that is flexible, secure and easy to use. In short, these difficulties, the complexity we've talked about, should be hidden to the users, from the users. Okay. So now, to meet these challenges, the challenges we've discussed about, the design of distributed operating system must deal with several design issues. There are several design issues, and these design issues are the ones that we are trying to discuss. Okay. Are we following, colleagues? Are we together? So the design issues, so we have the aspect of transparency. We are saying a distributed system that is able to present to a user and application as if it were only a single computer system is said to be transparent. Okay? So this is a distributed system that is able to present itself to a user and applications as if it were only a single computer system. Okay? So here what we are trying to say is that the issue of transparency, it comes in a sense that we are trying to ensure that when a user is accessing an application, or trying to access another machine that is remotely on the user should know to say, um, this is what happening, this is what is happening. They should be able to know that they are actually using a system that is just, it should appear to them as if it's just local to them, that they're the only ones using and accessing the resources. Now there are several types of transparencies in distributed system. We talked about we have what we call access transparency. This one hides the difference in data representation and how a resource is accessed by the user. Okay, so from the word access, so the resource is hidden. Okay, it hides the difference in the resource in the data representation and how the resource is basically accepted or accessed. Okay, so what you are saying is that a good example is that a distributed system may have a computer system that runs different operating systems, each having their own file naming conventions. Okay, so these differences in the naming convention, as well as how files can be manipulated, should be hidden from the users and the applications. So the user should not be able to know for sure that the resource they are accessing is located on a different machine. That should be kept a secret. They shouldn't be able to tell that the resource they are using is located on a different machine. Then you have what you are calling location transparency. This one hides where exactly the resource is located physically. Okay? This one, don't confuse it with access. Here we are just talking about the accessing aspect. Okay? Where you don't, it hides the difference in data representation and how a resource is accessed. So when you're accessing the resource, you shouldn't know to say, okay, this resource runs on a different operating system, and this operating system has a different naming convention, and probably it is running on a it is running on an operating system that is different from the one that we are currently running on our machine. But for the location, this where we hide the resources, the resource location physically. Okay. So, and this, for instance, we are saying by assigning logical names to resources like yahoo.com, one cannot get an idea of the location of the web page's main server. Okay. So you have your email address called Joshua at gmail.com. So where we hide the domain server, you wouldn't know where we are using a common domain server, such as the gmail.com, yahoo.com, hotmail.com. You wouldn't be able to tell, and you wouldn't be able to know where the name server is located. Location transparency. Then we have migration transparency, where we are saying a distributed system in which resources can be moved without affecting how the resources can be accessed, as said, to provide migration transparency. Okay? So it hides that the resource may move from one location to the other. Okay, so what you are saying is that when you look at the at migration, you will be able to do, like, let's say in this class we all have different machines. We say we are located, we are using a distributed environment. Each one of you consider himself as an independent machine, or an independent machine that is located on a different location and so forth. What we are saying now is that when let's say someone is accessing a resource that is on Madam Bushra's machine, someone is accessing this resource, and now Madam Bushra is moving maybe from one area to another. Then as long as she's moving and somebody is accessing this resource, this person shouldn't be able to say shouldn't be able to know that the resource he or she is accessing is actually being migrated to another location or another device and so on. So that's the aspect of transparency. Then you also have relocation transparency. This transparency deals with the fact that resources can be relocated while it is being accessed without the user who is using the application to know anything. This one is again used, if you're not careful, you may end up actually looking at it in terms of, you may confuse it from the migration. But in migration, we are saying the resource can be moved without affecting how the resource is being accessed. Okay. So in this other one, we are talking about the relocated, what is being accessed. Okay. So here, there's one moving, another one accessed. That's the difference between the two. Example, using a Wi-Fi system on a laptop, okay, while moving from one place to from place to place without getting disconnected. That is relocation transparency, a very good example of relocation transparency. Okay. Then replication transparency, this hides the fact that multiple copies of resource could exist simultaneously to hide replications. Okay, So it's essential that the replicas have the same name. Consequently, as systems that support replication should also support transparency. Okay, so sometimes you may want to have the same copies of the may want to have the same copies of the same resource, okay, distributed in different environments and so on. So it's replicated, but this should be kept hidden. This should be kept hidden to the users. The user shouldn't really know to say this is basically what is happening. Okay, the user shouldn't even know that this is what is happening. Okay. Then we also have concurrency, transparency. Concurrence transparency hides the fact that the resource may be shared by several competitive users. Okay, so it shouldn't know that shouldn't know that the resources you are accessing are being shared by more than one users. So example, two independent users may each have, okay, they may each have stored what can we say, stored their file on the same server and may be accessing the same table in a shared database. So this, it means that as they are doing this, they are able to access the shared resource concurrently. Okay. And the other one should, the two users shouldn't be able to tell or to know that they are concurrently accessing the same resource. Okay. They shouldn't be able to know that that is basically happening. In such cases, it is important that each user doesn't notice the others, that the others are making use of the same resource. We are trying to hide the fact that the other users are using the same resource. There's also what we call failure transparency. This hides the failure and recovery of a resource. Okay? It hides the failure and recovery of a resource. It is the most difficult task of a distributed system and is even impossible when certain apparently realistic assumptions are made. Okay? For example, a user cannot distinguish between a very slow or a dead resource. Okay, some errors message come when a server is down or when the network is overloaded, of when the connection from the client is lost. So here the user is unable to understand what has to be done. Either the user should wait for the network to clear up, or try again later when the server is working. So we've seen situations whereby you're trying to access a particular site, and then you just get maybe an error 404. How many have ever seen that? They've ever tried to access the system and get an error 404? Okay, or any other. Okay, so you find that this is basically the fact that you really cannot maybe even tell that the server is down or anything is happening to that. So it's just some kind of hidden message. Okay, hidden message to ensure that the information is kept as open as possible for the user. Then you have persistence, transparency. This one hides if the resource is in memory or disk. Okay, it just hides if the resource is in a memory or disk. For example, object-oriented database provide facilities for directly invoking methods on storage objects. Okay. So first, the database server copies the object state from the disk, such as the main memory, and performs the operations and write the state back to the disk. So the user does not know that the server is moving between primary and the secondary. Primary and the secondary. So this is the persistency, transparency, and this is the summary of the transparencies that we have talked about. You have persistence, transparency, access, location, migration, relocation, replication, concurrency, as well as the failure. Here's the summary of the transparencies. We are saying in a distributed system, multiple users who are partially separated use the system concurrently. Okay, we have these multiple users, quite a number of users, distributed, partially separated across the globe. Okay, these, okay, they use in one way or the other the computer systems concurrently, but they do not have an idea to say this is basically what is happening. So now we are saying in such a duration, it is economical to share the system resources. Okay, it is economical to share the system resources, in this case the hardware as well as the software. Okay, all these resources must be shared. All these resources must be shared among the concurrent executing users' processes. However, since the number of available resources in computing system is restricted, one user process must necessarily influence the action of the other concurrently executing users process as it compete for resources. Okay, as an example, concurrent update to the same file by two different processes should be prevented. Okay, two different resources shouldn't attempt to provide update to the same file. This should be prevented. So concurrent update, concurrent transparency means that each user has a feeling that he or she is the sole user of the system and other users do not exist in the system. Okay, that is concurrent transparency. As you are using this distributed system and accessing resources, the resource that is spatially separated or located, you shouldn't have a feel to say there are also other people using that resource. You should feel like you are the only one. You are the only one that is using that particular resource. Okay, you are the only one. So for providing concurrence transparency, the resource sharing mechanism of distributed system must have the following four properties. Okay, this is for providing concurrency transparency. The resource sharing mechanism of a distributed system must have the following four properties. One, we're saying an event ordering property. Okay, you order the event. Okay, there should be a particular order. to ensure that all access requests to various systems resources are properly ordered to provide consistent view to all users of the system. There must be a particular order such that when the system is being accessed, one shouldn't, of course, even know to say there's another one ordering, there's another one actually that is trying to access the system resource. So one issue of concurrent transparency is event ordering property. Then the second one is a mutual exclusion property. Mutual exclusion property. In the operating systems, you've learned about mutual exclusion. This ensures that at any time, at most one process accesses a shared resource. Not all processes should be able to access a shared resource at the same time, because this will result in what we are calling a deadlock situation. Okay? To result in a deadlock situation. And to avoid that, there must be a mutual exclusion property. Okay, this which must not be used simultaneously by multiple processes if program operation is to be correct. So a mutual exclusion ensures that the resource of the system should only be used by one particular system or process at a time. Then we have also what we call a no starvation property. A no starvation property, in a sense that certain certain processes should not wait forever for a particular resource. Okay, so a no starvation property ensures that if every process that is granted a resource, okay, which must not be used simultaneously by multiple processes, eventually releases it, every request for what resource is eventually granted. Because we have the properties, we have the resources, the processes that are accessing the resources, but they cannot access this resource or you make use of them at the same time. All of them could be waiting for the resource, but what you are saying is that as long as there's a process that has made a request to access that particular resource, it should eventually be given access. One process or one system should not wait for a shared resource forever. Okay, that's what we are calling it, a no starvation property. Then you have a deadlock property. Okay, no deadlock property. This ensures that a situation will never occur in which competing processes prevent their mutual progress, even though no single one requests more resources than the available in the system. Okay, so you try by all means to avoid the deadlock situation whereby there's a resource, there's a process that want to use more resources than they are available. So these are the four properties. Okay, so these the four actually properties that helps us to provide a concurrency transparency in a distributed environment. Is that clear? Is that clear? Is it making sense? Thank you.
Yes, sir.
Okay. Let's look at the performance transparency. Um, the aim of performance transparency is to allow the system to be automatically reconfigured to improve performance. Okay, as load